Hi students, good morning. Today's our topic is to explain the essential condition for Haber process. This Haber process will continue in the next class also to study some more questions and like reasoning questions. So today we will introduce what are the conditions, what are the steps in that. As we have studied in the last class, NPK fertilizer is very important, okay, that nitrogen, phosphorus, potassium, and we have studied some important synthetic fertilizers like ammonium phosphate, ammonium sulfate. So all contains, use when you check you can see that all these compounds contains ammonia. So we need to prepare or manufacture ammonia in large quantities, not only for fertilizer, for other uses also. So the process which helps to make ammonia is called Haber process. Ammonia, the formula is NH3. The process used to make ammonia is called Haber process. The equation you can see here, N2 plus 3H2 giving 2NH3, that is nitrogen and hydrogen are mixed in the ratio 1:3 to get ammonia, and it is a reversible reaction. So we have studied reversible reaction one chapter in semester 1. There we have discussed in the beginning reversible reactions were so much headache for the scientists, but later they found out that it is very useful for them. For example, the manufacture of ammonia, that is Haber process, contact process, all these things we are using the reversible reactions. And here you can see the sign of delta H. So here you have to keep one thing in mind, the delta H is negative, so that means the forward reaction is an exothermic reaction. Then the backward reaction will be endothermic reaction. This all we have discussed in the last semesters, but still you have to recall all these things. If delta H is negative, that means the forward reaction is exothermic and the backward reaction will be endothermic reaction. Now first I'll tell you what are the conditions for Haber process. The temperature must be 450 degrees, pressure will be 200 atmosphere, and the catalyst iron. So we will discuss the conditions in the next class more detailed. Now we will just see these are the conditions we are using for the preparation of ammonia by Haber process. You can see here in the flow chart, this is a flow chart for the preparation of ammonia. See here the gases are mixed and scrubbed, that means the impurities are removed, and it is passed through a pump, and here it is compressed, then again it is passed through a converter. Here a different, the temperature and pressure is applied, and beds of catalyst is there. Our catalyst is iron. So here the reaction happens and it is cooled and you will get the liquid ammonia here. But here from the fourth cooler you can see arrows are going up. That means the unreacted ammonia and hydrogen, they are recycled so that the reaction, they can react again. So what happens? It helps to reduce the cost of the process. Now we will see from where we are getting the nitrogen and hydrogen. See, the two reactants are nitrogen and hydrogen. So nitrogen we have studied in this chapter itself. Nitrogen we are obtaining from the fractional distillation of air. So the nitrogen is obtained from air by fractional distillation. There we separated nitrogen and oxygen. Hydrogen by reaction with methane and steam. You can see here the equation. Methane is CH4, steam is H2O. We will get hydrogen. See here hydrogen is formed, or by cracking hydrocarbons. Cracking, breaking down of higher hydrocarbons. Usually we will get an alkene as one of the product. So either these two, one of these we can use for the preparation of hydrogen. Now the steps. The two gases are mixed, as I told you here, the two gases are mixed and they are cleaned to remove the impurities. and here you can see they are going to the compressor directly. So you can see here it is compressed until the pressure reaches 200 atmosphere. Now the next step is the compressed gas then flows through a converter containing a bed of hot iron, that is our catalyst, at 450 degrees. The temperature is 450 degrees. There the reaction happens, a reversible reaction with delta H minus 91.8. Now the mixtures are cooled. As we can see here, the mixtures are cooled to get the liquid ammonia. The ammonia runs into the tanks and stored as liquid under pressure. Now here you can see, as I told you here, the nitrogen and hydrogen are recycled to convert to the converter for another chance to react. See here, the nitrogen and hydrogen, they are recycled and they are passed again through the bed of catalyst, and the proper temperature 450 and pressure is applied so that they can react further and helps in the formation of ammonia. So these are the main steps. Still we have to go into details why these conditions are used, that we will do in the next class. So till now you have to write these all questions. Ammonia is manufactured by Haber process. How are nitrogen and hydrogen obtained? Write the chemical equation taking place in Haber process. List the conditions. Write the steps in Haber process for the manufacture of ammonia. Draw the flow chart. Draw the flow chart means this one. You can see this in page number 222, 223. Further, we'll do further in this Haber process in the next class. Thanks.